So in this video, we're going to start looking at the introduction to chapters 9 and 10. Chapters 9 and 10, I think, are probably my favorite in the whole course because we really start looking at drawing some conclusions and making some predictions based on a sample. Okay, so maybe you go and survey a few people, you collect a sample, and based on the results of that survey, you try to make a prediction what all people would think. Okay, so maybe you say, oh, in our survey, 30% of the people said chocolate chip cookies are their favorite kind of cookies. So based on that, we're going to predict what kind of cookies the entire population likes. So maybe it's, okay, well, 30% of our sample like chocolate chip, so we think 30% of the whole population likes chocolate chip. Or maybe it's a little higher or a little lower, and you start really making some conclusions. And so we're going to use something called intervals in Chapter 9, and then in Chapter 10 we use something called hypothesis testing. To gear up for that, we need to get a little bit more comfortable with some notation and some symbols, in particularly intervals. So let's look at a few examples of that, just to how to set up some basic intervals and understand some of the notation that we're going to use moving forward in Chapter 9, okay? All right, so one example here. In order to wrestle in the midweight division, a participant must weigh, sorry about that extra T there, a participant must weigh within 5 pounds inclusive of 98 pounds. We sometimes call E the margin of error. So this capital E represents what we call a margin of error. That's how much you could be off by, okay? In this case, E is 5 because they said that they wanted the participants to weigh within 5 pounds of 98 pounds. So if you think about wrestling, they split you into divisions by weight, okay? So if you have, older kids and younger kids, it's not just their age that is a factor of who should be wrestling against who. If you have two, 10-year-old kids and one of them is really, really tall and big and weighs a lot, it would not be fair to wrestle another 10-year-old kid who's little bitty tiny. That just wouldn't be a fair wrestling match. So they split them up by weight, okay? And if you're going to be wrestling against people with about your same weight, because that's probably pretty fair in terms of strength and that sort of thing. All right, so ideally, everybody in this midweight division would weigh exactly 98 pounds. But you're probably not going to be able to find every single person that weighs exactly 98 pounds. So they build a little window. They said, hey, as long as you're within 5 pounds of 98, you're okay. You could go above 98 by up to 5 pounds, or you could be under 98 by as much as 5 pounds. But you got to be within 5 pounds of that 98-pound target, okay? So Part A asks us to sketch a number line graph. So in the middle, I'm going to put 98 because that's what I want each kid in that division to weigh. But they could go as much as 5 pounds above. So 98 plus 5 is 103, so they could go up to as much as 103. Or they could go as much as 5 pounds below. So 98 minus 5 is 93. So their weight could be as low as 93. And I went a little beyond that, but anywhere between 93 and 103 would be an acceptable weight for a kid to be in this wrestling division. So also note that they said inclusive, so that means that exactly 93 and exactly 103 are okay. So I would put a little squared off bracket at 93 and 103, and I'm going to shade in between. Anywhere in this interval would be acceptable for kids in the midweight division. Part B, express acceptable weights for the midweight division as an interval. Okay, so that means, just like was when we did intervals in the previous unit, okay, we're going to put either a parenthesis or a bracket for where it starts, and then a parenthesis or bracket for the last number. So 93 was the lowest someone could be, and it could equal 93, so we're going to bracket it. And 103 was the highest, and it could equal 103, so I'm going to put a bracket. So remember, intervals tell us where it starts, where it stops, and then we either bracket or parentheses, okay? And then part C, this is a little bit new for us. Write an expression in X plus or minus E form, sorry that M got chopped off, to represent the interval. Okay, so when I say this X plus or minus E, X is going to be the ideal number, what you're aiming for. In this case, it was 98. plus or minus E. Remember, E is our margin of error. E was how much we could be off by. So in this case, the kids could be as much as 5 pounds different, 5 pounds above or 5 pounds below. So we're going to say the X plus or minus E form is 98 plus or minus 5. Okay? Notice if you took 98 plus 5, you would get to the last number in the interval. If you did 98 minus 5, that'd be 93. That would give you the lowest number in the interval. So this plus minus form is just a different way of saying it. Okay? All three of these things represent the same thing. The graph is more of a visual approach. The interval tells you where the graph started and stopped. And then the X plus or minus E form, notice that's the only time 98 ever showed up. 98 is your middle number. So it's your middle number plus or minus however far it is to the edge. Okay? All right, number 2, same idea but different scenario. A polling company estimates that 62% of the voters favor candidate A, but their estimate could be off by as much as 3 percentage points. Okay, so a lot of times when an election is coming up, there will be polling companies. And so these are places that either call or email or knock on people's doors or whatever, and they say, hey, who are you going to vote for in this election? And you say, oh, I'm planning on voting for, whoever, Smith or Jones or Davis or whoever you're going to vote for, okay? And they say, okay, and they, based on what percentage of people say they're going to vote for a particular candidate, they say, oh, we think this percentage of the voters favor this person, okay? So based on their survey, they're saying, hey, 62% of the people are expected to vote for candidate A. But they know that even though that's what their sample shows, that it might be different on the actual voting day. Some people may change their mind, okay? They were going to vote for candidate A, but by the time the election actually rolls around, they change their mind and they vote for somebody else. Or maybe they were going to vote for A, but they forgot to go vote that day. So their vote didn't actually go in the pile, okay? So, they know that even though they're predicting 62% of the people to vote for A, that they could be off. And they're saying they could be off by as much as 3 percentage points. Okay, so part A, they want an expression in X plus or minus E form. Left off my M there again, sorry. To represent the interval. Okay, well, we're expecting 62, but we know we could be off by as much as 3. 3 is our margin of error. Okay? Now, I'm cool with you just putting 62 plus or minus 3. I would point out that since these are percentages, it might be better for us to use decimals because usually we can't do computations with percent. So if you put 0.62 plus or minus 0.03, that would probably be better, but I'm cool with 62 plus or minus 3, okay? As long as you realize that once you get your intervals and stuff here, that you're dealing with percentages, not whole numbers, okay? All right, part B, sketch a number line graph to represent the percentage of voters who are likely to vote for candidate A. Okay, so a number line graph, in the middle we're going to put 62. That's how many we think are going to vote for them, or the percentage. We can go up by 3, so 63, 64, 65, or we could go down by 3, 61, 60, 59. But we know somewhere in there is probably the percentage of people that are going to vote for candidate A. Okay? Write an interval. Well, again, we started at 59 once we had it in our number line form, and the highest it would go is 65. And then they ask us, do we think candidate A is going to win? Well, if candidate A gets 59, that means candidate B, we assume, gets the rest. 100 minus 59 is 41. So if candidate A gets 59% of the vote, they're going to get 59% compared to candidate B's 41%, because that adds up to 100, so A wins. If candidate A got the highest predicted percentage here, 65%, then that means B would get everybody else. 100 minus 65 is 35%, and candidate A still wins, 65 to 35%. So assuming that this interval is correct and candidate A gets anywhere between 59 and 65%, they're going to win. Okay? So yes, A should win even if they are off by 3%. because the lowest that candidate A could really go is 59, and that's still more than 50%. So we are going to expect candidate A to win. Now notice that's not a guarantee. Okay, again, some of the people may change their mind by the time the actual election rolls around, but at this point, we're pretty confident that A is going to win the election. Okay, now if this interval had been from, let's say, 47 to 53, I would not be so confident, because if A was down here at 47, that means B would be over 50%. And so, that's what we call, almost a tie. Like we don't know who's going to win because, 50% could go to either of the people. But since in this case, the lowest A could go was above 50% at 59%, we're pretty sure A is going to win. Okay? All right, let's try another similar example here. Temperature range for a typical day in May in North Texas is 65 degrees to 90 degrees. So they want us to graph the range of temperatures for a typical day in May. Okay. Now what's interesting about this one is they did not tell us the middle number. They told us, hey, it's anywhere between 65 and 90. So I know 65 is the low end and 90 is the high end, but they did not tell me what the middle is. They said, hey, it's going to be somewhere between 65 and 90. Okay. So there's my graph. And I could count by ones, 66, 67, 68, 69, 70, all the way up to 90. I don't really feel like doing all that numbering. But, we could. Now, part B, they want that x plus or minus e form to represent the interval. Well, the problem is this format, remember, we need the middle number. We need to know what's in the middle plus or minus however far we're jumping over to either side. Well, we don't know either of those things. So we need to figure out what the middle number would be. Now, we could kind of guess and check, but if you think about it, the middle number has to be halfway between 65 and 90. So what I could do is I could average together 65 plus 90 and divide by 2. I could average them together and get the mean, and that ought to be what my middle number is. So let's try that. 65 plus 90 divided by 2 is 77.5. 77.5 ought to be the middle number. It ought to be halfway between 65 and 90. If you want to check, what's 77.5 minus 65? 12 and a half. So it's 12 and a half degrees from 65 to 77.5. And 77.5 plus 12 and a half is 90. So 77.5 plus 12.5 puts us at 90. So what we've done is we figured out, okay, 77.5 is in the middle. That's the middle temperature. That's the average day in May. Plus or minus 12.5, because it could go as much as 12 and a half higher or as much as 12 and a half lower. So this right here is our x plus or minus e format. Notice that margin of error, the e, is 12.5, because that's how much you could add or subtract to get to your endpoints. Okay, so our margin of error is the 12.5. Okay, all right. As we move forward into chapter 9 and 10, there's going to be some critical thinking situations that we just have to kind of pay attention to. It may be a situation you're familiar with. It may be a situation you're not familiar with. And you've just got to sometimes kind of think about, okay, should the answer be higher? Should it be lower? What do I know? What do I not know? So let's just practice a few kind of examples with that. All right, Josiah has calculated that his final grade after the final exam must be between 87 and 92. While he's waiting for his professor to grade the final exams and post final grades, he wonders the following. Okay, now let's think about this situation. Josiah has taken his final exam, but he does not know what his grade is on it. Okay? But he thinks about it, and he's like, I felt pretty confident on this question, and this question, and this question. I had to make a guess on that question, so I'm not positive exactly what I'm going to get exactly. But I think my final grade is going to be somewhere between 87 and 92. I think the lowest it's going to be is 87. I think the highest it's going to be is 92. Somewhere in that range is what I think I'm going to get in the class. Okay? So, he's kind of, thinking about that, and he wonders, I wonder if I'm going to get an A in the course. Now, when they say conclude, that means, is he confident? Is he deciding, yes, I'm going to get an A, or I might not get an A, not so sure? Okay? Well, if he gets the 92, if he's on the high end of his predicted grade, then yeah, he's going to have an A. But if he gets the 87 or 88 or something on the low end of his prediction, he will not get an A. So can he conclude he's going to get an A? Can he be like, yep, I got an A. I know it. I'm confident I'm getting an A. No, he cannot be confident in that. He cannot conclude it for sure. He might get the A. He could go up as high as 92, he thinks. But he can't conclude for sure that he's going to get the A. Okay, part B. Can he conclude that his grade will be at least a B? Is he confident that he's going to get at least a B? Yes. Even if he's on the low end, he's pretty sure he's going to get between 87 and 92. Even the low end, 87, is going to be a B. So he knows he's going to get at least a B. He's not worried about getting a C. He knows he's going to get a B, possibly an A. All right, part C. Can Josiah conclude that his grade will be higher than 88? Can he be confident that his overall grade is going to be higher than 88? That's a no. Okay, because it could be as low as 87. He's already kind of preparing himself for it to be as low as 87. That's not higher than 88. Part D, can he conclude that his grade will be higher than 85? Well, if the lowest he thinks he could get is an 87, then yeah, that's still higher than 85. So yeah, he knows he's going to get at least an 85. He's confident of that. Okay. All right, number 2. Still, got similar, not exactly grades, but similar idea. A school counselor is charged with identifying students who may need special services based on their reading scores. Students more than 25 points from the mean on a reading test are identified for special programs. Answer the following. Okay, before we look at these questions, I think a little number line graph may help us here. They do not tell us what the mean score is, what the average score is on this test. But they say that students who are more than 25 points from the mean are identified for special programs. So if you get 25 points above the mean, anywhere between the mean and 25 points above it, you're okay. You don't need anything special. But if you are beyond 25 points above the mean, you need some special services. Okay? Probably if it's reading scores, maybe you need some gifted, you maybe are gifted in reading and maybe you need some special services. On the other hand, if you are below the mean, if you are below average, if you're just a couple points below average, that's not any big deal. You don't need anything special. But if you're 25 points below the mean, that's starting to be a cause for concern. So if you're more than 25 points below, your reading speed is well below average, and they might need some special services to help them with their reading. Okay, maybe they need some kind of extra tutoring or something like that. Okay, so part A. Student A scores 30 points below the mean. Do they need special services? 30 points below the mean. Well, here's 25 below. So 5 below, 10 below, 15 below, 20 below, 25 below, 30 below. Is this person more than 25 below? Yes. So do they need special services? Yes, they do. Okay. Student B scores 20 points below the mean. Do they need special services? Well, here's the mean. 20 below would be about right here. They are definitely below the mean, but are they beyond the cutoff? No, they're not beyond the cutoff. So no, they do not need special services. Okay. C. Student C scores 27 points above the mean. Do they need special services? So they're above, they're on the high side. Here's 25 above, here's 27 above. Yes, they're beyond that 25-point cutoff. So yes, this student will need special services. Part D. Does a student scoring 35 points above the mean, that would be about right here, and 35 points below the mean, that would be about right here, need the same special services? In other words, this person's more than 25 away, they need special services. This one's more than 25 points away, they need special services. Do these two people need the same thing? Well, no. This person may be, a gifted reader, and this person may have a learning challenge and needs some special help or some special tutoring. You cannot put them both in the same program and say, oh, you need something different. Here you go. No, they need different things from each other. So no, those students do not need the same thing. They both need extra help, some special services, but not the same thing, because one of them was higher and one of them was lower. It's like if your blood pressure is too high, you may need medication or medical treatment. If your blood pressure is too low, you may need medication or medical treatment. But the person who's too high and the person who's too low don't need the same thing. If you give them the same thing, you probably kill one of them. So they need, opposite treatments, if you will. Okay. These last two. We do not know how to solve these yet. These are both examples of some problems that we're going to see in Chapter 9, and we'll learn how to work in Chapter 9. But what they're wanting us to do right now is just read through it and pick out the key facts. Pick out the key pieces of information that we're going to need so that when we get to Chapter 9, we can pick that information out and learn how to solve the problems, okay? All right. A random sample of 10,000 Americans who are age 15 or older are surveyed. The mean amount of time spent eating or drinking per day is 1.22 hours with a standard deviation of 0.65 hours. Calculate a 95% confidence interval for the mean amount of time Americans age 15 or older spend eating and drinking each day. Okay, lots of information there. So they are interested in how much time Americans spend eating or drinking. Okay, and maybe that's different for Americans than it is for people in other countries. Okay, and so they're just kind of comparing them. How much time are they, sitting in a chair eating or drinking or that sort of thing. Now notice this age 15. I don't really think it has anything to do with the problem other than it might be different for adults, how much time adults spend eating or drinking versus how much time little kids spend eating or drinking. So they're just trying to say, hey, we talk to only people who are age 15 or older. We didn't have little kids in this one because it might be different for little kids. So they only talk to people who are 15 or older. Okay? A random sample of 10,000 Americans. Okay, so that's our sample size. That's how many people were in the survey. Okay? We learned early in the year that we use the symbol N to represent our sample size, how many people were in the survey. So N is 10,000. The mean amount of time spent eating or drinking is 1.22 hours. Okay? That's the mean amount of time. That's the average amount of time. Since this 1.22 is an average or a mean, and it's from a sample, we're going to use X bar. We're going to say, oh yeah, X bar is 1.22. That's the mean. Now, if this had been the mean from an entire population, we would be using mu. Okay, but this was not from the whole population. It was just a sample, so we're using X bar. And the standard deviation is 0.65 hours. Okay, again, this is a sample, so our symbol for standard deviation sample is S. If it had been a population, the standard deviation would be sigma. Okay, but ours is a sample, so we're using S. And they want us to calculate a 95% confidence interval for the mean amount of time Americans spend eating or drinking. We do not know how to find a confidence interval. We're going to learn that in Chapter 9, but notice that's what they ask us to find. Okay, so Part A, what's the stated sample size? Okay, well that's N, so 10,000. What was the sample mean? And again, they reminded us that the correct symbol there is X bar, so that was 1.22. What was the standard deviation? That was the symbol S, so 0.65. And then what was the goal? What are they asking us to find? They're asking us to find a 95% confidence interval. And you don't know how to do that yet, but you will soon. Okay. All right, number 2. A lot of reading here. School administrator is concerned about the amount of credit card debt that college students have. She wishes to conduct a poll to estimate the percentage of full-time college students who have credit card debt of $2,000 or more. In a prior study, it was found that 34% of randomly selected college students had credit card debt of $2,000 or more. What sample size should she obtain if she wishes her estimate to be within 2.5 percentage points with 95% confidence? Okay, so let's back up and think this through again. She's worried about how much debt her college students have, okay? So she's like, well, are my students having more debt than others or less or the same? Or, how much debt does a typical college student have? She decides to start with that. So she says, in a prior study, so maybe the administrator before her or an administrator at a different school or something, said, hey, 34% of college students had credit card debt of $2,000 or more. Okay, that's an old study. Okay, all right. So what we will learn in chapter 9 is that when you have an old study, an old sample, okay, we use the symbol p hat to represent the percent of people in a study or in a sample. So 34% of the people in her survey or in this old study that we had that we knew about had a specific credit card debt of $2,000 or more. So we're going to say that p hat, that percentage, was 0.34. Okay. The reason it's got a hat on it is it's because it's from a sample, not a population. Okay. When it's from a sample, we use p hat. So 34% of the people in a sample had $2,000 or more credit card debt, so 0.34. Okay. Now, notice she wants her estimate to be within 2.5 percentage points. Okay. That's a margin of error. Okay. So remember how earlier in this video we said, hey, margin of error is E. So if you want to be within 5%, then your margin of error is 0.05. So she wants to be within 2.5 percentage points, 2.5%. So we're going to say that our E is 0.025. Remember, we can't usually work with percents in problems. We have to make them decimals. So 2.5% would be the decimal 0.025. That's her margin of error because she wants to be within 2.5%. And she wants to build a 95% confidence interval. Okay? All right. So what is the stated margin of error? Our margin of error, our E, is 0.025. What is the stated sample proportion, p hat? That's 0.34. The stated level of confidence. When she does her work, she wants to be 95% confident. Again, usually we'll use decimals for that because you can't really work with percents in problems, so we usually make it a decimal. And what is the stated goal of the question? What did they want us to find? Well, they said, what sample size should she obtain? So we're trying to find a sample size. And what you'll discover as we get into chapter 9 is that they will give you a formula to use for this. If you're trying to find the sample size, how many people do you need in your survey? There's a formula that you're going to use. And you'll have to find these values from the prompt and plug them into your sample size formula to calculate that.